To understand how forecasters use radar sources to indicate how much precipitation an area is going to get, you'll first need to think of a color chart. And I want you to imagine that green is in the middle and is neutral, and that's going to show us kind of light precipitation. Going from the center to the left, that's going to indicate snow, and going from the center to the right, that's going to indicate rain. And there are other ways to interpret the data, but for the purposes of this video, we're going to keep it simple. The colors are called reflectivity because they are reflecting the moisture or the precipitation that's in the air. All right, so now that we know what the radar is and how the colors are utilized, let's go ahead and see what it looks like kind of on a broader system. So I'm going to start with that green, that kind of neutrally color, and I'm just going to draw a very wide system. So you might see something like there's a system and they'll say, oh, there's a frontal boundary, and you'll see a lot of green, okay? This green indicates lighter rain. So you'll see that this is a very wet system. It's across multiple states, and it's gonna kind of cause a lot of ruckus, as you will see. So sorry, North Carolina, you're out of our coverage area. All right. So now we've got this wide system. You'll see sometimes that there's like little clusters here and there. You might notice they call them cells. And the reason for that is they are circular. I mean, honestly, that's really all it is. It's a simple kind of singular pattern. There could be cells inside of the main system, but you're going to see these pockets of more concentrated color. And those are the ones that are going to kind of cause a little bit of calamity. So I'm going to zoom in more on the Chattanooga metro area and get a bit more descriptive. All right, folks, we are back, and I've gone ahead and grabbed the yellow, which is going to indicate a little bit more of a heavier rain. Okay, and I'm going to mix that in. Y'all, this is not how they do it. They use computer graphics, but this is just, again, to give the simplicity of it. So there's some yellow bands. Chat, you're getting hit with some yellows all the way up onto Knoxville. All right. Now, something that often will show up in the middle of those yellows is you'll see those more intense areas. So I'm going to grab the orange and start to kind of focus on the interior of my yellow area. So now it's starting to resemble something that you would see on TV or even on your weather apps or computers. Okay, Birmingham, we're going to give you a little bit. Okay, so I'm going to do a little bit of a broader area of orange. And again, not anything precise. We just want to kind of give an idea of what we're going to see with these intense storms, okay? So let's look at a cell. I'm going to make like a perfect cell, okay? So this circle here, south of Atlanta, I'm going to kind of color around it with the yellow. It's an intense little pocket there, okay? And then you see that it goes kind of, there's orange around it. So what I'm going to do now is you've got these two here, okay? And right in there, this is pretty intense, and you've got this orange, okay? So what's happening is, let's say that this system is traveling northeast, okay? You've got this kind of coming northeast. So these areas of intensity are going to be moving kind of right toward Atlanta. Okay, so I've zoomed in on the Chattanooga, Birmingham, Atlanta metro areas here to kind of show you what the next phase might be. So we've got a lot of this intensity here. Here's that cell that we were talking about earlier. And right in between there, you've got some really big points of interest here with these more orangey, we call them bands. Okay, and we call them bands because they can tend to be straight like this. With that cell in particular of interest, we're going to get some red. And again, right, it's kind of rounded, kind of off by itself. And you'll also, if you've ever looked at a radar before, you'll have these like little pockets, little reds in there. Okay. All right. So let's say that we've got some reds outlining this storm, okay? Chat, you're getting a pretty intense storm there, okay? And you've got kind of, you can really start to see it really resemble something that you would see during a storm. All right, so let's go back to Atlanta. Atlanta, you're going to be my area of interest here. Sorry about that. And I am going to kind of get some reds going here, and we're going to go back down to this cell in just a second. I want to intensify that more. So now you can see it's pretty well defined, and I'm going to start using words that you would hear on a forecast. That way you can start to connect those pieces, okay? So this area right here, this cell, okay, let's call it a supercell because it's kind of big. It's pretty well identified. It is pretty intense on the radar, and we've noticed that here's the front here, all right, because that's where most of the precipitation and the kind of the strong rains are. But ahead of that front, so out in front of it, right, is going to be some of these cells, all right? So let's see what happens and why these cells might trigger a warning. All right, so now we are pretty zoomed in to the Atlanta metro area. So you will notice on radar that when you get pretty zoomed in, you'll start to see like little speckles. Now remember, this is quite pixelated, okay? One little dot blip on a radar, that could cover, you know, a pretty good portion of a zip code. You never know because this is such a zoomed out map, even though I'm so zoomed in, right? Like the city of Atlanta is not the size of a crayon tip. The city is much bigger and much larger than that. So if I just do a little dot, whoop, with my crayon, you know, right there, that's not indicative of just some tiny little blip cloud, right? This is an entire formation of precipitation. But back to Atlanta. So I'm going to grab kind of my red violet crayon here, and I'm going to get really intense with this cell and some areas around it too. But I'm going to get really dark around it because I'm going to show you what's going to happen and why some warnings get triggered, okay? All right, so remember we said that this storm is moving kind of northeast, okay? Coming in. So anytime you see that dark maroon, red, I'm trying really hard to make it dark, but you know, I'm coloring over green, so it's not working so well, okay? All right. Because the radar is picking up velocity, velocity is movement. We're talking about velocity, or the movement of clouds and of vapor and of basically moisture in the air. So we're really tracking the movement of clouds and rain and just an entire system. So what the radar is telling us is the radar is saying, okay, you've got a whole lot going on here, and it gets kind of intense up in this area. So if I were a forecaster for this area, I would zoom in even further. Whatever township this is just south of Atlanta, this is pretty intense. And I might even kind of go off and say that this area here needs to start preparing for some heavy things to go down. I think that this area here is going to be seeing it pretty soon as well. So let's talk about what watches and warnings will mean. So more than likely by now, there have been some warnings in the Atlanta metro area for this particular cluster of storms right in this area. Okay. A watch means, hey, we're watching things. They may unfold, they may not unfold. A warning means, hey, they're happening, okay? And there are different types of warnings when it comes to tornado warnings or hurricane warnings. They can mean different things, and I'll go more into that on a forecasting video. But for purposes of this video, I'm going to insert a graphic, and it's a very commonly known graphic that shows the difference between a watch and a warning, and it has tacos. So I'm going to insert that here. Okay, so as you can see, we have all of the ingredients to possibly have a situation here near Atlanta. And it doesn't mean we're going to issue any warnings at this time, but we are watching. So this area could potentially be already under a severe thunderstorm watch, maybe even a warning, depending upon how close to the red and to the maroons you are. And if the storm path trajectory is this way, these areas very close to it, kind of up ahead of where the storm will be in the next, hour or so, they'll issue warnings as well. And it's all going to be based upon what the radar is suggesting for movement and speed of these storms. Now, sometimes a warning will be issued based upon the radar and not necessarily a storm spotted confirmed tornado on the ground. And I want to use this term because a lot of times it will say capable of producing a tornado or radar indicated rotation or whatever it is. Okay, let's talk about what that looks like. So I want you to focus on the cell right here to the south of ATL. And we're going to come back in with that more intense, I guess. I was trying to make it more intense, but it's not working out that way. That more intense color, and I'm going to draw something that looks like this, okay? All right, so I drew it bigger so you could see it on radar. It might not be that big, but what it is, okay, remember that the radar is an echo, okay? It's bounced and it's bounced back, and whatever it echoes is what they are going to use to predict. So this right here is called a hook echo, okay? When you see a cell that looks like this angry, intense red, and it's got some of the outer maroons, and you see this little hook thing, it's called a hook echo. You see something like this coming down, that is radar indicated rotation. Okay, so they have gotten information that this cell is starting to rotate and drag in moisture and intensity from other clouds. So typically it will drag in from a storm around it. And when it does, when the clouds and the wind start to rotate, we know what happens next. So this would more than likely put out a warning for a radar indicated tornado or radar indicated rotation or debris signature. There is a time when storm debris gets kicked up into the atmosphere and is reflected on the radar. So meteorologists can actually see, oh, there's a tornado on the ground, because we can actually see what it's picked up and it's spinning within this system. It shows up as a different color. So this is when a warning will be issued based upon radar indication, okay? It will say capable of producing a tornado, radar indicated rotation, hook echo signature, whatever terminology and combination of words that they choose to use. I've heard all of them used before. This is what that means. It means, oh snap, there's that hook and things are about to start rotating, so we have to warn these people. And then a warning will come. All right, so this warning, even though no one on the ground has said, yeah, guys, there's a tornado, we're saying, hey, the chances are highly likely. And I don't know about y'all, but I'm not going to wait till, there's one in front of me. I want to be prepared and take cover when there is the chance, or when they start to see rotation. Like, that's the time to go. That is go time. That is get in your safe place time. We are not going to go outside checking the clouds and looking. We are not going to want to go see for ourselves. By the time a trained spotter on the ground confirms that there is a tornado, more than likely it was already indicated on the radar. Can you spot the hook echo in this picture by Waverly? So now I have zoomed back out, and I'm going to show you the opposite side of that, which is going to be the more wintry mix of precipitation. And I'm going to kind of use the state of Tennessee as an example. And Nashville, lucky y'all always get all of the good stuff. Okay, so here is an indication to us on the radar that this is rain, but it is cold rain. It is either going to be freezing rain or it is going to be sleet. Just kind of depends on atmospheric conditions and temperature, to be honest with you. So I'm going to actually zoom in to Nashville, and I'll show you what else can be seen in these types of systems. Okay, so on the colder end of the precipitation spectrum, there is a purple color, which is my favorite, and it indicates like a mix, okay? So what do I mean by a mix? I mean a mix of this good old freezing rain and what is coming behind it. So this little mixy area, think of it as the boundary between who's getting only freezing rain and sleet and who's getting the good stuff. Okay, so Nashville, y'all are getting a nice wintry mix, but don't worry. Okay, remember, this storm system is moving northeast. Okay, so we would expect to start seeing some stuff right about here. And the more intense the color, obviously, the more intense the precipitation. So I'm going to give some light spots out here. All right, so here comes the stuff we've all been waiting for. Now, you will have two colors. One will be a very, very kind of soft blue. And I'm going to bring it around like this because Nashville knows it's coming. And then you will see more intense blue to indicate the heavier snow. All right, so let's talk about what is happening right here in the middle. So between these two areas of the moisture, why is it like this? What goes from intense storms with rain and lots of wind and, capable of producing tornadoes? Where do we go from that to intense snow? What is going on here? Well, the boundary between these two is called a front. You will hear that, a frontal boundary or a cold front or a warm front. A warm front is going to be red and a cold front is going to be blue. And you'll see they have these triangles, and that's just indicating what direction it's moving. Okay, so we've got a lot of wind, and I told you this was moving northeast. So at first, it's got to kind of come down a little bit, and then you can see like it'll start to move. You'll notice if you start to look at still images and maybe future casts that the line, the frontal boundary, it will move. And so it'll start to sweep a little bit like this to indicate that it's taking that more northeasterly direction. So yes, there is going to be moisture and precipitation happening at the front. It's not like a magical stopping point, but this front indicates where the most kind of velocity is going to be happening with the winds and such. So this is all going to be warmer air. This is all going to be cooler air. Where the warm air and the cool air meet, that's going to be where you're going to have the most volatile winds and volatile conditions, because what's happening here is the cold air and the warm air rises. Okay, cool air sinks. So you've got the mixing of these two systems of air here, like that, with wind. Okay, the wind is blowing. This cold front is bringing in those cold temperatures, and the wind is blowing. So as one is rising and one is sinking, and they're blowing at the same time, going that northeasterly direction, what's going to start happening when these start to rotate and spin? Okay, and I did mention that, things can get volatile ahead of the front, and that's just because things are just kind of unstable. You'll hear that term also, that the atmosphere is unstable. You'll hear things like, that the front's pushing in and it's pushing all these different storms forming ahead of the squall line, things like that. So a squall line is like this. It's like a long band. Okay. And it's called a squall because it is really just coming down hard and intense. Okay. And you've got these cells out ahead of it. Again, that hook echo with the rotation. Things are just not really looking good between Birmingham and ATL right here. This is looking pretty intense. And then with the snow up here, you've got, again, kind of that freezing rain, but behind it, remember, because we're moving this way, behind it is going to be the snowy conditions. And then as far as this, kind of where they're mixing, remember, this is going to be some intense wind here and some unpredictable storms at the time. So I hope that made reading a radar much easier to understand. So I've gone ahead and zoomed way in on a potential supercell that I have so nicely scribbled for you in this demonstration. Now I want you to remember what I said before about what looks like a single blip on a radar can actually span across a town. And I'm going to demonstrate that now by drawing some county lines. So these are just going to be pretend county lines, okay? This is a line, okay? So this county, definitely along the edge here, the extreme northern county, if this were moving like this, would get a warning here because of this hook echo. And then this county, they should already have been warned about the potential for something severe, and now they're about to get a warning ASAP. Okay, if another county line were here, similarly, since it's moving northeast, it is going to go into the next county over pretty quickly. So that's why you'll get things that will say extreme northeastern county A, extreme southeastern county B, and extreme western county C. That's because they are quite literally tracking this singular cell that is going to be rotating. Now, this looks like a comma or a kidney bean or even a J. If you see something like this, or even the backwards mirror image of it, because it can most certainly go both directions, this is going to trigger those warnings. So I hope that this gives you a basic understanding of how you can read a radar and how you can be better informed for when the potential for severe weather heads your way. Thanks for watching, guys. I'll see you next time.